So what we have here is our two boxes, our two fog misting machines with the ultrasonic misters set up. I also have a full video that breaks down how I built these fog machine ultrasonic mister totes and everything, along with a parts list. That's in the description in this video as well. What we're going to be doing is we're going to be running a couple different tests. Some of these tests that we're going to run is a ice versus no ice, fan intake pull versus push. As you can see right now, we have it set up where it's going to pull. So this is pulling the air from the tote and pushing it out. And this one's set up to actually pull air intake and push it through the box. So we'll see which one works better. And we'll also set it up with the fog machines to see which one works better. I have a theory that this is going to potentially cause issues when the fog machine is spraying, because it will potentially block some of the intake for the fog machine to spray into the tote. So we'll see how that works when we get that set up. So for our test here, we have the same amount of water in each tote, right up to a little fill line down here. It's the same on both of them. We have very similar water temps. We have about 72 Fahrenheit in this one, about 75, 74 in this one. So we're going to turn these on. Again, same exact setup, same ultrasonic misters, except for that this fan is going to be sucking the fog mist out and blowing it out, while this one is actually acting as an intake, and it's going to blow it in and add a positive pressure and blow it out that way. So I'm going to close these bins up. We'll do some tests to see what looks best and what gives us the best results. So we've closed up the bins, and both of these fans are on the same settings, on a low setting. What you can see thus far already is that this one doesn't have any fog that is, or mist rather, that it's kind of pushing out, because it's not a positive pressure, it's a negative pressure, so it's sucking air in through this intake, which eventually will have the elbows on it for the fog machine. However, this one, that's acting in a kind of push-pull method, where the intake is actually pulling air in and putting a positive pressure. You can see that there are some leaks here. That's because I don't use any sort of seals. If you have a tote that has seals, you won't have that problem. But let's see what it's actually looking like down on the output side of things. So both are pretty similar. I'd say, again, the one on the left is acting as the push. This is acting more as a pull. Looks a little bit, potentially a little denser. So a few potential differences. It looks like the pulling of air rather than pushing is here on the right is maybe producing a slightly thicker fog with just the ultrasonic mist compared to the left. I think that's mostly due to the fact that it's able to pull a lot more compared to this method. I'll turn these off for just a second. So if you look at the pulling method, it's kind of pulling it mostly from the bottom area. So it's not getting maybe the full flow of air compared to this method, which is creating a positive pressure from this air intake. So you're kind of getting the full fan effect that's able to push all of it compared to pulling, which seems to be pulling more kind of from the bottom. We'll see how this works out with the actual fog machines all set up. I will say that this method will need a much more secure and sealed tote than this method though. Alright, we have our test set up with the push configuration, where it's pushing the air across the box, rather than the pull configuration, where it's pulling the air out and going through. For this test, we're using Bog Fog from Froggy's Fog, and we're using our 1200 watt Titan Froggy's Fogger. So let's test this out. My primary concern is that we're going to get a potential backlog here, but we may not. So we'll see how this goes and test it out. So it's a short burst. I am getting a decent amount of leaking because I don't have it sealed, so you might have better results. But we're getting a nice low lane fog effect. Now I want to see if we actually get any sort of backlog there, so I'm going to run it to, let's say, 30 seconds, or until it shuts off. Alright, I ran it for 20 seconds, and I got a lot of fog on the back end here compared to the front. So if you have a better seal, it might work a little better for you. However, I was getting a lot of back pressure here, which was kind of forcing it out and about compared to where I want it to go more, which is out that way towards the decorations and things like that. However, either way, it's still working really nice. So next what we'll do is we'll test the pole configuration, so that box over there, and see how that performs with a max pressure and see how much leakage we get there. Alright, so we have the same setup as before, fog machine, air intake, with the same distance here, and you do want some distance as this will kind of create like a Bernoulli's principle effect, which will pull additional air in. Now, in this case, we actually are in the pull configuration rather than the push. So the push configuration is acting as a air intake and pushing the air across the box, while this has the fan over on the outtake, and it's pulling the air from the pipe through the box and out. So let's see how this reacts, specifically looking for any sort of back pressure here, because what I don't want is I don't want it spraying all around here. I want it to go where I'm directing it, which is out the piping and flexible tubing. So let's try it out. We're going to do another kind of 15-20 seconds. I'll do the same 20 seconds that we did for the previous one. I'm not getting any back pressure, which is good. It's all getting pushed in there. Any leakage is just coming from the box itself. Otherwise, we're getting it going where we want it to. So to me it looks like we're getting a little bit more going the route that we want, which is out towards the decorations, compared to in the back here. There's still a decent amount of leaking coming from the tote, so that's something that we could definitely improve upon. But something I'm not too worried about and concerned right now. So for now, I think my preference is actually to have it in the pull configuration with the fan over here, away from the intake. So it's fan on the outtake. That's giving me more fog going that way rather than getting any sort of back pressure. I am getting a ton of leaking throughout the tote, so that could be something to improve upon. But otherwise, I'm not getting the back pressure that's spraying fog everywhere compared to going in the direction that I want. Let's get to the next test, which is ice versus no ice. All right, we're set up with ice and no ice, and we've now gone to the same configuration for both. So they're both in the pull configuration, meaning they're going to be pulling air across the totes rather than pushing it across. So they're going to be pulling the air from inside the tote and pushing it out. So this is going to be the coldest that it gets in a typical night, because this is just when I've just put the ice in and have let it melt. So we're right around 50 degrees Fahrenheit. So again, it's only going to get warmer from here because these ultrasonic misters put out a lot of heat. And this one has been running for about maybe 10 minutes or so. Again, we started around 74 or 75 degrees Fahrenheit, and we're now at 78. So we'll turn these on and we'll do some tests. We'll do tests within the garage itself, and then we'll do some tests with the garage open and testing out the cold air outside, which is around 58 degrees Fahrenheit with a slight breeze, which will mimic a nice Halloween night as well. All right, first impressions, we have ice on the left, no ice on the right. The ice is hanging a little lower than the no ice, so that's potentially promising for when we actually add fog to this. Now again, these are the same exact setups, just ice, no fans on right now. This is the very first test, just to see how it reacts. So the no ice is kind of hovering around, moving around a bit, while the ice is hanging real low, not even coming out of the box, while that one is coming out of the box, the no ice. So again, we have ice on the left, no ice on the right. And right now, there's no fog being mixed in, just the ultrasonic misters. We're just running the fans on the lowest speed. Might be slightly hard to see on the camera, but the one on the left with ice appears to be producing slightly less, at least visually. However, it's also hugging the ground more, so that might be why it's visually looking like it's not producing as much. So again, we have no ice, ice, pretty steady stream, and with ice, you're still getting a steady stream, but it doesn't appear to be as thick. So we might not be producing as much, or maybe the fan isn't pulling enough. We'll see how this looks with the actual fog machine as well. One other test we can run is to see what the temperature is. So we're getting about 57 degrees on the output here, and this is with ice. We're getting 66 degrees with no ice. We have the fog machine set up here with the ice setup. I've turned the fan off on the no ice just so we get an only ice type effect, and we can see how that performs. So again, right now, the no ice has been off for about a minute or two. This is the effect with just ice and ultrasonic mist. Let's run a little bit of the fog. So it's hugging the ground really nice and low. It's nice and thick. These pumpkins are about 1.5 feet, 2 feet tall. It's hanging just around there, staying really low to the ground. We'll do a temperature with the fog itself. .64 degrees. So it's definitely cooling it off quite a bit. Let's see what the temperature is as we're firing it. .105 degrees. Again, we've been running this for about 2 minutes now. It's still just hugging the ground. Again, this is no wind inside of a garage, but we will also test this outside with some gentle breeze and cool air. It's been about 5 minutes since we ran the ice configuration. Still hugging the ground really nice. Again, no wind inside of a garage, so this is going to be different than outside. But already from testing previously with no ice, when we were doing the push-pull configuration tests, the fog is already hanging much lower than previously. Previously it was spraying all over the place and kind of getting much higher. So we'll do another test and see how that works out. Alright, we've set up the no ice configuration. I've even swapped the hoses to get the same test as accurate as possible. Same elbows, machine, everything. So again, that was ice, no ice. It's been running for about 30 seconds to a minute. Already we can see that it's not hugging the ground as much, though we are seeing a slightly denser cloud. We'll see how that works once we actually do some fog. So we're going to run the fog for about 10 seconds, see what we get. Alright, we ran it for 12 seconds there. We're still getting a very nice effect. It's still hugging the ground really nicely. It's maybe slightly higher. We'll have to do a comparison to see if this is denser in comparison to the ice version. It's getting slightly higher on the pumpkins, but still hugging the ground very nicely. Do a temperature test. Getting 73, 75. So both ice and no ice produce amazing effects either way. We'll do a side-by-side comparison to see which one we like better. We're also going to do a test with the garage door open and outside with a slight breeze and a cool weather and see how that performs there. Alright, we're outside. There's a very, very slight breeze, less than a mile or two per hour. And this is just the ultrasonic mister with no ice. This is the effect right now. You're going to run the fog machine and see what happens. Again, this is no ice. It's hugging the ground pretty well. Now we're testing the ice version. Fan on. So we have the same setup, just with ice now. Okay, we're doing the ice fog test. Seems to be a little windier right now. The other thing that I'm not seeing as much is that effect where the fog kind of holds onto the ground. I'm wondering if that's because we get less output from the fog mist. We get a drier, cooler fog, but it's not hugging the ground potentially as much. We have the same no ice configuration. Testing it again to see if we get any differences with potential wind changes, weather, things like that. think potentially the best way to utilize these machines is actually in short bursts. That way you're not overwhelming how much fog is going into the tote, and it's keeping the density as a good mixture. Otherwise, if you're spraying too much, it just becomes all fog. It doesn't hug the ground as much. So definitely play around with it, see what works best for you and your conditions, and hopefully you don't get any wind on Halloween night. I think this was a pretty surprising test for me. I was heavily leaning towards utilizing ice, while it seems that this test has actually shown that the no ice version can hug the ground a little bit better because it's a little denser, while the ice version works really well if there's absolutely zero wind or maybe in an indoor setting. It doesn't work as well in an outdoor setting. Here we have a side-by-side comparison of using ice versus no ice. These are both on a low fan speed setting. The ice version and no ice version, they're both working pretty well, but the ice version is kind of showing that it's not hugging the ground as much. So my conclusion here is that it's not as dense with the ultrasonic mist, thus it's not as heavy. So it's actually kind of getting blown away. And so while it may, in a inside setting, work better and stay low to the ground, which be careful of any smoke detectors and smoke alarms, ask me how I know. But in the case of an outdoor application, it looks like no ice is actually better because of the fact that it's denser, and so the water molecules will kind of hug the ground and stay low to the ground and be a little denser, won't get blown away as easily with any sort of wind that may be on Halloween night. The other thing is that throughout the night, the tote is going to warm up anyways, and you're going to get to the point of being in a no ice type of configuration anyways, so you might as well just start out that way. That's the plan that I'm going with, is no ice, fan on low, and short bursts of the fog machine. Next, we also have a comparison of no ice with no fan, low speed fan, then high speed fan. In this case, I like the no ice low speed fan the best because of the fact that it's continuously pushing out some of the fog that gets trapped within the tote. Because once you're no longer spraying any fog from the machine in the no fan configuration, you don't have any pressure pulling and pushing anything out of the pipe, so it kind of dissipates a little easier. Now in the high speed setting, it kind of blows it too much and pushes it a little too fast, and it dissipates a little too quickly for my personal taste as well. So I like a low, medium fan speed and no ice for my configurations this year. I think one of the biggest takeaways here is actually needing to seal my totes as much as possible because we're getting a lot of leaking and that fog isn't going where we want it. Okay, after about 2.5 hours of recording the video and everything and having these misters running, this water is at about 55 degrees. There's still some ice in there. While this water that did not have any ice is at about 83. Alright, so some lessons learned. I was actually really surprised by the fact that the no ice version is actually the way that I'm going to be going after doing these tests. But ultimately, I'm going to set it up with a fans in a pull configuration away from the fog machine intake in order to avoid any sort of back pressure. I'm also going to be utilizing the fans on a low or medium fan speed setting to avoid kind of spewing out the fog too quickly. Also, I'm going to look back and do some actual proper sealing of my tote lids to try to avoid leaks. I was losing a lot of fog that way, so I want to avoid leaks as much as possible. I'm going to go back and do some sealing. Like I mentioned earlier, no ice. The warmer water creates a denser fog that appears to be, in my testing, attaching to the ground better and kind of hanging around low. The ice version works great for a completely zero breeze, zero wind, maybe indoor warehouse type setting, but for a typical outdoor application, I'm going to go with no ice. The warm water works great. Also, fans are not operating at the full capacity. This is something I noticed. So proper sizing or moving the fan to a vent blower setup external of the tote. I was seeing that the fan blades were kind of not fully able to push the air through the pipes and everything like that. So I'm going to experiment with doing a vent blower type setup a little later, maybe do some 3D printing, encase the fan so that it can actually utilize the entire flow rate of these fans and get some better flow rate through these flexible tubings and things like that. So I hope this was really helpful. I learned a lot from it. I hope you did too. And happy Halloween.